Now see this question that has been asked in GATE 2009 for 4 marks. Here we have to find VTH and RTH across these terminal AB. Okay, and VTH is for 2 marks and RTH is for 2 marks. In this circuit, this is a dependent voltage source which depends upon the voltage through this terminal AB. See, we can solve easily this question by using a method that is VXIX method. We assume a voltage Vx across this terminal AB and a current Ix in this direction. Okay. But here in this circuit, Vx is already given. Now after assuming Vx and Ix, we write the circuit equation in the form Vx is equals to Aix plus B. If we write the circuit equation in this form, then this A will represent the value of Thevenin resistance and this B will represent the value of Thevenin voltage. Okay. So see, we will try to write the circuit equation in this form. What is the resistance through this 1 kilo ohm resistance? That is equals to Vx. So we can assume current in this 1 kilo ohm resistance is equals to Vx by 1. Now what is the current in this branch? That is equals to Ix minus Vx by 1. That is equals to Ix minus Vx by 1. Now suppose current here is I. Now what is the current in this branch? That is simply equals to I plus Ix minus Vx. Now we have completed the current distribution in every branch of this circuit. Now we simply apply KVL equation. First apply KVL equation in this loop. Then we get 5 is equals to 2I plus 2I plus 2Ix minus 2Vx. Okay, so on solving this we get 2Vx is equals to 4I minus 5. This is our first equation. Now we will apply KVL in this circuit. Okay. Now we will apply KVL in this circuit. So on applying KVL we get 5 is equals to 2I plus 3Vx plus 3Vx plus Vx. Okay. So here we get I is equals to 5 minus 4Vx by 2. Now put the value of current I here. Okay. So when we put value of current in this equation, then we get 2Vx is equals to 4, and what is I? That is equals to 5 minus 4Vx by 2 plus here this 2Ix was missing. Okay, so plus 2Ix minus 5. So here on rearranging this equation we get Vx is equals to 4 5 is 20, 10 minus 5 So finally we get this equation that is in the form Vx is equals to Aix plus B. Here A is equals to RTH is equals to 0.2, and what is B? Here B is equals to VTH is equals to 0.5. So what is RTH? RTH is equals to 0.2 kilo ohm, and what is VTH? That is equals to 0.5 volt. So this is the solution of this question. See how we can easily find both VTH and RTH by using a single equation. So if we use this method, then we can very easily solve such type of circuits, and it will also take very less time. Now see this question. Here we have to find Thevenin voltage and Thevenin resistance for this circuit. Okay. So in this circuit also we will use again the same concept. This is Vx given and this is dependent current source that depends upon the voltage Vx. Suppose we assume current Ix here. So you have to be careful while assuming the direction of current. We have to take the polarity of Vx like this and direction of current always like this. Okay. Now we can write by applying KVL in this loop. Okay, so here current is 0.01 Vx. So what is current in this branch? It will be equals to Ix plus this current 0.01 Vx. Okay, because current is 0.01 Vx. So these two current will add. So here current will be Ix plus 0.01 Vx. Now we can apply KVL easily. So we can write Vx is equals to 100 plus, here this positive terminal is encountered, so 100 plus 20k into Ix plus 0.01 Vx. This is current. Okay, so we can write Vx is equals to 100 plus 20,000 Ix plus, what is this? So it will become, if we multiply this, so it will become 20,000 into 0.01. It means 200 Vx. Okay, now take Vx this side, so we get 199 Vx minus 199 Vx, that is equals to 20,000 Ix plus 100. Now take this minus 199 here. Here we will get 199 minus, and here we will get minus 199. So what is VTH? VTH is equals to, this is VTH and this is RTH. So what is VTH? VTH is equals to minus 100 by 99. Sorry, what I have done wrong. Sorry, 199. Okay, minus 100 by 199. And what is RTH? That is equals to 20k by 199. Here both are negative. Now what is negative resistance means? Means this resistance acts as active element, or we can say that network is active.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.